Hi everyone, this is me Jennifer, Assistant Professor, Department of Information Technology from Madurai Suhasinada Pioneer Meenakshi Women's College, Puvandi. Today I am going to handle a small topic in cloud computing. These are the topics I am going to cover today. In cloud application, what are the design considerations, reference architecture for cloud applications, cloud application design methodologies, data storage approaches. First, we are going to see about the design consideration for cloud applications. Okay, the first thing is we are going to see about the scalability, reliability, availability, security, maintenance, and upgradation performance. These are the things we have to consider before going for designing the cloud applications. First is scalability, and scalability is an important factor that drives the application designer to move to cloud computing environment. Building applications that can serve millions of users without taking hit of their performance has always been challenging. With the growth of cloud computing, application designers can provision adequate resource to meet their workload levels. Before we have going for the scalability, we have to find the benefits of following these considerations. First one is loose coupling of components, asynchronous communications, stateless design, database choice and designs. First, loose coupling of components. What is the meaning of loose coupling of components? The components which are going to use for building the designing the cloud application should be a tightly coupled application. That is, all the applications we are going to use should not be a tightly coupled one. Should be loosely coupled uh, because the component we are using in this cloud applications should not make it difficult to scale the application components independently. Okay. Next, asynchronous communications. In traditional approach designs, it is a common practice to process a request and return immediately. This limits the scalability of the applications. By using this, it is possible to add capacity by adding traditional servers with the application load increases. Stateless design that stores state out of the component in the separate database allows scaling the application component independently. Then next one is a database choice and design. Before we are going to design the cloud application, we have to choose the database and the design of the data storage that should not affect the application scalability. Decisions such as whether to choose a traditional relation database or a schemaless database should be made carefully for analyzing the applications. Next, second one is reliability and availability. Reliability of the system is depend on the probability that the systems will perform the independent functions under conditions for the specified amount of time. Availability is the probability that the system will perform a specified functions under given conditions at a prescribed time. Important thing to implement reliable and available systems are no signal point of failures. Uh, Third one is security. Security is an important design consideration for the cloud applications. What are the security we have to need for our environment? Securing the data in motions, authentication, authorization, identity and access management, key management and data integrity and then auditing. Maintenance and upgradation. This is a very important phase of the design considerations. So whenever we complete designing our cloud application, we have to maintain and we have to do the upgradations. What is meaning of maintaining? maintaining should be done yearly wise or monthly wise to achieve the rapid time to market business. Okay, and upgradation is that whenever application is on application is maintenance, upgrading time is very important to do this. In application with loosely components, changes can be made to the component without affecting their other components. So performance, application should be designed while keeping the performance requirements in mind. Performance requirements depend on the type of the applications. Application with experience high database read intensive workloads can benefit from read replications or caching approaches. Then second one is a reference architecture for cloud applications. Okay, so when we are going for developing the cloud application, we need some defined architecture. So what is the type of architecture we are using here is a multi-tiered cloud application. For choosing the right deployment architecture is important to ensure that the application meet the specified performance requirements. Deployment architecture are used to build applications like e-commerce, business to business, banking and financial applications. Load balancing tiers. Load balancing tiers considers of one or more load balancer. It is recommended to have at least two load balancer instances to avoid the single point of failure. Whenever possible, it is also recommended to provide the load balancer intents in separating availability zone of the cloud service provider to improve reliability and availability. This is the reference architecture for cloud application. This diagram represents the reference architecture for cloud applications. In this, first we have the website. In that next tier we have the load balancer. In next tier we have the application server. And this server has, as usual, we have the master and slave. And master will be getting the information, will be sending the queries to do the action, and slaves will be doing all those instructions. Okay, all the things will be saved in the database tier. Then application tier. In this application tier, it is the second layer. It contains one or more application servers. For application tier, it is recommended to configure auto scaling. Database tier. The third tier is a database tier which include a master database instance and multiple slave instance. The master node server at the write request and the read request are served from the slave nodes. This improves the throughput for the database tier, since most applications have the higher number of read request than write request. Multiple slave nodes also serves as a backup for the master node. In case of failure of master node, one of the slave node can be automatically configured to become the master. Then fourth one is storage tier. For both master and slave node, it is highly recommended to use a disk subsystem for storage and not the instance attached store. This is important to ensure reliability and availability, because in the event of failure, if the instant attached storage is used for the database, all data will be lost. In case of separate disk volume, it is possible to restore the database. Regular snapshots of the database are recommended here. It is recommended to store the snapshots in distributed persistence cloud storage solutions like Amazon S3. These are the example of the cloud deployment tool. First, in Java, we use this type of tools. In PHP, we use this type of tools like Zend server, In .NET, we use the Internet Information Services. In Python, we use the Django and mode Python, mode swings, paste. This is the typical deployment architecture for content delivery applications. Okay, so this we have seen already. We have the website and we have the load balancing tier. Then next one is application tier. Next one is a database tier. In that database tier, we have the traditional relational database. Whether we can use a non-relational database or we can use the relational database, and with this help of database, we can store the data in the cloud storages. Like what are the data we are going to save here is like media, images, videos, and then audios. Next, this is the thing where cloud-based distributed batch processing infrastructure, and here the inputs will be given and the inputs will be worked according to the worker, and this workers will send the output in the queue. Then cloud application design methodologies. In this, we have the SOA, that is a service oriented architecture. It is a well established architectural approaches for designing and developing application in the form of service that can be shared and reused. SOA is the collection of discrete software modules or service that form a part of an application and collectively provide the functionality of the application. SOA services are developed as loosely coupled module. The service communicated with each other by passing messages. These are the concept of WSDL, that is service, endpoint, binding, interface, operations, and then types. Service describes a discrete system function that is explored as a web service. Endpoint is the address of the web service. Binding, it specifies the interface and transport protocol. Interface defines the web server and operation that can be performed by the service and the input and output. Operations defines how the messages are decoded and the actions that can be performed. Types describe the data. And this is the cloud application design methodologies we have seen. Now we are going to see about the layers of SOA, that is what are the layers we are having in SOA. First layer is a business system. Second, a service component. Third, composite service. Orchestrate business process, presentation service, enterprise service bus. These are the layers which is in SOA. Okay. First layer is a business system. This layer consists of custom build application and legacy systems such as an ERP. And second service, it allow the layer about to interact with the business systems. Next, composite service. This is there in composite service can be used to create the enterprise sale component or business unit specific components. Orchestrate business process. In this layer, it orchestrates the composite service or defined to create the business process. Presentation service. This is the topmost layer that include user interface that expose the service and orchestrate business process to the users. Enterprise service bus. In this layer, it integrates the service to adapter, routine, transformation, and messaging mechanics. This is the cloud methodology, that is layers of service oriented architecture, which we have discussed about, that is presentation services, enterprise services bus, service components. What are the service components we have? And this diagram shows the layers of service. And this is the CCM, that is cloud application design methodologies. We have the design steps, that is component design, architecture design, and deployment design. component design. So in component design, it will be identifying the building blocks of the cloud applications, which are classified based on the functions performed and the type of cloud resource are required. Each building blocks perform a set of actions to produce the desired output for other components. Components have number of resources like web pages, images, documents, database tables, etc. This is the architecture of CCM component. And next one is, this is the deployment design steps for the e-commerce applications. Then REST is the representational state transfer. It is a set of architectural principle by which can design web service and web API that focus on the system's resource and how resources states are addressed and transformed. RESTful web services can support various internet media types, and also it can collect the resources which represent by the URL. Then last topic is data storage approaches. There are two main categories of database approaches. First one is a relational approach. Second one is the second one is non-relational database approaches. In relational database approaches, this is the relational database that conforms to the relational model. A relational database is a collection of relations or tables. Relations is the set of tuples or rows. Each relation has the fixed schema that defines the set of attributes or columns in the table and the constraints of the attributes. Database constraint. In database constraint, we have two, that is domain constraints, entity integrating constraint, referential integrity constraint, and foreign keys. In database constraint, first one is a domain constraint. Domain constraint restrict the domain of each attributes or set of possible values for the attributes. Entity integrity is, that is this states has no primary key values can be null. Referential integrity constraints, and this constraints tuples in two relations, each value of one attribute of the relation to exist the value of another attributes in the another relations. Foreign key, for cross reference between the multiple relationship, foreign keys are used. To provide relational transactions, relational database provides ACID properties, that is ACID properties. ACID is nothing but atomicity, consistency, isolation, and durability. Atomicity is that transaction is either all or nothing. Consistency is that each transaction brings the database from one valid state to another. Isolation is a property that database state obtained after a set or concurrent transactions is the same as would have been if the transaction were executed serially. Durability, the durability property ensure that once the transaction is committed. These are the pros and cons. Next one is non-relational approaches. This is becoming popular with the growth of cloud computing. Non-relational do not provide the ACID guarantee. These are some of the general categories of records. First one is key value store, document store, a graph store, and object store. First, key value store. This key value store database are suited for application that required storing unstructured data without a fixed schema. Most key value stores have support for native programming language data type. Document store database stores semi-structured data in the form of documents. Graph stores are designed for storing data that has a graph structure. Object store solutions are designed for storing data in the form of objects defined in the object-oriented programming language. These are the pros and cons. So what are the pros and cons is that here it is easy for scale out and here it is not easy, and it will be very fast to relieving of data. Here the performance will be somewhat slow. Okay, go through all this pros and cons. This pros and cons will be helpful for designing the cloud applications. I hope you all enjoyed this video. Thank you one and all.